My name's Ron Sattler and I'm from Chemetall, and I'm here to talk about the application of sustainability in metalworking fluid processes. Now that's a mouthful, but really the ideas behind this are: why is it critical to the future of business to adopt the sustainability principles, particularly as it pertains to metalworking fluid processes and manufacture? Okay, so for a brief overview of what we're going to talk about here is a few of the business drivers in the metalworking industry which pretty much create the need for the types of sustainability principles. Then we'll move into sustainability, and then how do we apply these sustainability principles to the development and application of metalworking fluids. And finally, how do you engineer a sustainable solution, and what are the steps that are involved in inputting that into a process. So here's our four main business drivers that we have for a capable process in metalworking. You have environmental restrictions, cost, productivity, and safety. Cost, I mean, we all know that there's cost inputs into a metalworking fluid process. That's direct use, scrap, energy, the things that we're putting in there that have tangible cost to them. On the productivity side, we really need to look at these types of processes as being process capable and having a certain amount of productivity so we can have the necessary return on capital employed that is directed by our senior management. A couple of the ones that are often overlooked are environmental restrictions. With the continuing tightening and restriction of materials, not only here in the United States but globally, it's becoming more and more difficult and more important to stay environmentally sustainable in these in regards to metalworking fluids, because it's limiting the amount of flexibility that we have. Lastly, we have the safety piece of this, and safety is more than just using safe materials, which is something that I think most companies try to do. But also there's a certain risk factor that's involved anytime that you're manufacturing a process or running a process. And so in regards to safety, we really need to minimize any risks that could be associated with that. So to kind of move on how this has all come about from a timeline standpoint, we'll go back to like the 1850s. Before that, I don't know, they had oxen and water. I think that's what they machined with. Okay, so now we move on. Around the late 1800s, people started using straight oil. Oil before that was such an expensive commodity, they really didn't use it for machining or mass production. There wasn't a lot of mass production. So they began with straight oils. As we move into the early 1900s, this is where water dilutable fluids had come into vogue, and where they've developed the emulsifier type technologies that are common with simple soluble oils. We get up into the 40s and past the 40s and the 50s. Now we're looking at EP additives that are put in there to really enhance the machining characteristics that you can receive out of a metalworking fluid. Get up there in between the 50s and the 80s, that's when the synthetics showed up. Now they didn't show up in the best of forms back then, and they've come a long way. But that's when people started thinking about, hey, let's get rid of the oil. The oil is a material that has some secondary issues with it. And then we moved, okay, well, we're back to oil. So that didn't work out so great in the 70s, and a couple of the people here in the audience are old enough to know what the old experience with the synthetics were. But the semis came on, and that really kind of came on strong. Then after that, we started looking at these non-mineral oils. They were called neosynthetics at some point, and they were like vegetable-based materials. And that was kind of a step forward in some of the lubricity and environmental compliance with some fluids. And then if we move up past the 1990s, the hot term in the industry right now is biostatics. And biostatic chemistries were developed for longevity and for the maintenance of certain properties within the fluid. So that's kind of a timeline, and so then we go, okay, so what's next? That pretty much brings us to a really comfortable place in the industry. Well, if we really take a look at it, the first portion of this metalworking development, as far as history goes, it was all about productivity. How many machine gun barrels can we get out? And it was really how fast can we run? How many cars can we get out? How many gears can we get out? So the development was focused on productivity. If we look at that second piece of it, okay, so now we get some global competition coming in. Now everything was really kind of focused on cost. How can we make more parts cheaper, maintaining that productivity? The last piece that I talked about there was the environmental and safety piece. Now we're starting to get restricted because of the number of manufacturing locations that are out there and some global problems with water and things like that. So that was kind of the three major steps. So the next step is how do you pull all of this together and take one more step forward into something that's called sustainability. So now I'd like to move on to kind of a definition and just a brief overview of what sustainability is. If we look at a traditional business model in a company, we all work for the man. Okay, don't let anybody kid you, cash is king, right? That's the first thing they teach you in a finance class, cash is king. So shareholder return, whether that the shareholder is an owner or if it's a stock, you know, on the stock market, shareholder return runs the business. Okay, to achieve that, you need to achieve your business goals, which is a function of your corporate strategy, which is a function of overcoming business issues. So that's a pretty simple model, and that model has been around for a long, long time. Now, you know, it identifies the needs. I'm not going to go through everything down there, but really it's a very simple model. It's worked very, very well. But if we're talking about sustainability, where does that exactly fit in there? It's a very short-term model, and for those of us that work primarily in the United States, we know that we have sometimes a shorter view of returns. And so sustainability really doesn't fit well into that model. If we look at what a core sustainable development definition is, and I'll actually read this one, development which meets the needs of the present without compromising the ability of future generations to meet their own needs. Well, that's just like a big hug from your grandmother, isn't it? I mean, it's very broad, but it's very complex in its simplicity. It's essentially saying that what we do now is a function of what we will be able to do in the future. So it's really a longer-term view of how we want to do business now to create the ability to continue to do business in the future. If we look at really a sustainability model, and this is the traditional model, you have the three P's, people, planet, and prosperity. What that comes down to is the social, economic, and environmental components of a process, any process. You can make paper, you can make machines, you can be an insurance company. All these things come together, and they're considered the pillars of sustainability. And if you look at the model, and we've all seen these models coming up through school, it's that intersection of the three of those where you get the overlap, the positive overlap of the three of these that really helps you hit a sustainable development. So a couple more definitions. I'm not going to read through these. Economic sustainability, environmental, and social. So each one of these has its own definition, which it has to do with how do these three components take place in a within a chemical process or any manufacturing process. A couple other definitions, and I'm just going through these very briefly to just try and touch on the concepts. But environmental impact, everybody thinks that environmental impact is a negative. Environmental impact is neutral. You can have a positive environmental impact, you can have a negative environmental impact. And the measurement of that environmental impact is what's important. Green chemistry. Now, this is one I'm going to kind of hit on because I work for a chemical company. Green chemistry doesn't mean that we use corn silk for the manufacture of everything in our products. What it means in the definitions through the kind of global sustainability community is that it's the design of chemical that eliminates or reduces end use or waste or toxicity. So it doesn't mean that everything that we use came from corn or wheat. What it means is that the use of these materials is reducing some negative effect after it. So when you walk down the aisle at the grocery store, everybody wants to be green these days. Well, not everything that's necessarily in a green product is, you know, from Mother Earth. Carbon footprint, we hear a lot about that. I just wanted to put that definition up there. but it's really the measurement of CO2 units. And that's important from a business standpoint, because not only, you know, it's great to say, well, I reduced my carbon footprint, but we will be regulated by it. Particularly from an industrial standpoint, you will get regulated by that.